we got introduced to free fall. It's a very simple scenario wherein we have an object, any kind of object, even a person as well. If the object is falling only under the influence of gravity, it's said to be under free fall. And we can ignore what initially the things were. Was it thrown? Was there a push by a propeller? We are not going to look at that. At that moment of time, is it only under the influence of gravity? If it's yes, then it's said to be under a free fall. Okay, so here we are going to understand about the free fall by simulating it. So what is the main agenda over here? To observe the free fall of an object every second of its journey. We're going to take the initial velocity to be 0. Right? So let me show it, then it will make sense. So first thing is the free body diagram of the object. So what we have here is an object. We have the force acting on that object, and this force is your gravity. And we are taking that it was not thrown, it was just left. Right? So u is equal to 0 meter per second. Just for the sake of clarity, I'll also mention the time. Right? So this is your scenario. What happens? Well, it's tough for me to actually take a video and show it to you guys, because first thing is I will need a very good camera, and second thing is that for more than few seconds it's tough for someone to take a shot. Right? It's only for a fraction of a second that someone can simulate this, not for like 4-5 seconds. It's tough. You will understand why in time, because of the distance that we need. Okay, so let me show you guys a simulated version of this. So to help us simulate this, we're going to use, can you see this? We're going to make use of this. What is this? Can you tell that? What is that? It is one of the equations of motion. S is equal to ut plus half at square. I'm taking negative over here. You can see that it's negative because it's a fall. Up is positive in this simulation, down is negative. So I have to take minus gravitational pull, acceleration due to gravity. Okay guys, okay, chalo. So let's simulate this. Can you see that? What is happening? That's a ball under a free fall. Okay, I have not let it fall forever. I imagine somewhere here is the ground. We just need to see what is happening. So I entered the simulation over there. So let's see what is happening. So understand this, that this is a scenario wherein for every second we are looking at the object, what is happening to that. Okay, so we took a photo over here, and after a second another photo after a second. So this is a time gap of 1 second. Got it? So it's a snapshot of an object under free fall per second. Okay, we're taking a snapshot for every second, right? A gap of every second. So what's happening? The distance, is it increasing? Right? It's increasing, is it not? So this is what is happening. Why is it increasing? How can we explain this? This can be explained with the help of F is equal to m into a, right? An object will accelerate provided there is a force acting on it, and there is a continuous force, and that force is gravity. Got it? You can see over here the first 4 seconds of the journey is just covered, it's covering only this distance, while this is the next 5 seconds. Can you see the difference? If you look at the next 4 seconds also, it's this much, right? This is known as an accelerated motion. Okay, so let's look at the next thing, that is your graph. So the graph is on the same thing, the same simulation. Let's analyze this. The graph part of the fall, we're going to make use of distance time graph. So the title is distance time graph. We are going to ignore the scale. We are going to ignore the values, right? Because I've not taken it as falling under the influence of gravity. I just took it under falling under the influence of some other gravity. and the value will not make sense to you guys. So for now, I'll just ignore this. So you can see every second what is happening. The distance traveled by the object, it's increasing, is it not? Can you see that? So every second, fourth second is over here, fifth is over here, sixth is over here, seventh is over there, and eighth is over there. If I project it onto a single line, say over here, how does it look? Well, I'll just do a rough work of this. Right? Oh yeah, I'll start from the bottom. So this is the top. And after a second, it's over there. After a second, it's somewhere over there. Right? Makes sense. Fourth second. Fifth second. Sixth. Seventh. Can you see that? It's similar to what we just saw. Right? Obviously, this is the distance time graph. It's a normal scaled distance time graph, not a log. And so we'll be able to see this. Don't worry, whatever I said, I should have not told you about log table. Can you see that? It's a ultra version of whatever we just saw, the fall. Right, guys? So this is an exponential growth. For such a exponential growth, if the distance time graph is exponential, can we tell that the object is accelerating or is it not accelerating? Yes, the object is accelerating because the object is continuously pulled down by the force of Earth's gravity. Right, guys? Basically, instead of telling so much, I can just air quote it as free fall. The object is under free fall. Object is under free fall. Make sense? That's it. Got it? To put it, to make this simpler to write and to talk, they just use the word free fall. That's it. Got it? Right? So I hope you guys understood a lot more about free fall. I know you guys would have understood, but again, it's to concrete your idea. Please understand the free body diagram. That's important. This is important for me. Everything else is something I am sure you guys will understand. I'm sure of this and all, and hopefully this as well. Distance time graph, right? It's very simple. Okay, again, pause. Please write everything. Don't miss anything. It's all diagrams and stuff. It's fun. So please write everything.